Hey y'all, welcome back. Hope you're all well, and thanks for joining me again. Today on my bench I have a Harman Kardon PA2100 power amplifier. It's a nice unit. It's a this is part of their signature series, and the signature series being built up to a little higher standard than their regular line. I guess that's what the marketing schmick is. But let's look at this specifications for this 2100. It has a continuous average power per channel, 20 to 20 kilohertz. At 8 ohm loads, does 65 watts a channel, and that's with a 0.09% THD. And this thing will also handle 4 ohm loads with the switch on the back. What it does is it sets up the power supplies for a different load. And it has some impressive numbers for 8 ohms, 4 ohms, 2 ohm loads in the dynamic power category, and in both high current mode and high voltage mode. But yeah, it's not bad. It boasts some other pretty good specs too. Frequency response of 0.3 hertz. 0.3 hertz, I don't know how they measured that. And up to 250 kilohertz, and that's within plus minus 3 dB at 1 watt. It's got 120 volts a second slew rate, which is impressive. Damping factor of 100, signal to noise ratio of 115 dB, and yeah, it's an impressive amplifier. It's got some really good specifications, and this one came to me in unknown condition. I don't know if it works. I'm assuming it does, but I have no idea. It's got some nice features too. It has an automatic, I'll show you, turn this around. Really nothing to look at the front other than a power button and a power light. Has your input signal, and you have a switch for bridge mode, and right now it's set to off. But you can bridge this amplifier for a 135 watt output in 8 ohms in a bridge mode. You have an auto standby feature, which senses when you turn on your preamplifier. If it senses a voltage swing or a kick, it turns on the amplifier to start working, and I think it holds it for 2 minutes and then shuts off if there's no signal. But if it senses a signal, it turns on the amplifier, which is a good thing to have, because you know, especially if you're doing these in monoblock configuration, you have 2 amplifiers, you don't want to be turning both on. 2 speakers, right and left channel only, and then you have your switch for 4 ohm load, 8 ohm load, and what it does is it sets up the power transformer and the power supply to supply a higher voltage in 8 ohms. And then you have no courtesy outlets, and that's it. So, like I said, I don't know the condition of this. I'm assuming it's working, so let's pull the lid off and have a look inside. Alright, so what do we have here? We have a chunk power switch here up front, a massive power transformer. It's not plugged in, by the way. It's quite a hefty iron core in that one. Whole lot of empty space in the front here. It's all vacant space, but we have a nice sized heatsink and power supply. Capacitors are 13,000 microfarad. Everything else is on pretty much one board. This is the amplifier board, and then at the back we have another board. I think this is probably input signal conditioning. This is the power on detect. So let's see that. I don't see a relay to turn on the amplifier. I guess they're using some kind of a solution where it goes into a sleep state, and that these capacitors remain charged at all times. I see there's no secondary power supply to keep the unit alive when it's shut off or when it's in standby mode. it relies on full mains power on this transformer, and then when it senses a signal it just kind of takes the amplifier out of mute mode. So I don't see anything going on here. I don't see any blown fuses. I don't see anything smoked or burnt. So maybe we could hook this up and see what it's capable of doing or not doing. Alright, we're all wired in for a power test, and I've got scope on both channels, input to tone 1000 Hertz, and I'm going to vary the amplitude from the signal generator. Let's turn this on, and we are in standby mode. Let's try turning on the output, the input, and turning this up. And the amp does get sensed, and it does go into come out of standby. So everything's working so good so far. Let's turn this up, see if we get any signal on our outputs. This is coming up nice. I got to adjust the speed here. I'll just keep turning this up. We're into clipping already. So let's turn this down. So we're into clipping already. I'm going to hook up a voltmeter, and then we'll see what kind of voltage we get out of this. Just give me a second. Okay, I'll take it back up to clipping. Oh, here, let's do this. Make it better, easier to see. Let's turn this back up to clipping. Right there. I'm feeding in 2.4 volts peak signal, and I'm getting out 24.4 volts RMS. So I'll just let this go for a while. Waveforms look good, everything looks clean. Just going to let this go and warm up. Barely warm now, and it's at full power, so I'll give this time to cook. Alright, so I'm turning it down. It's been about 5 minutes now, 5-6 minutes, full power. This thing's getting quite hot. It's dissipating 150 watts, and this is starting to warm up. Starting to warm up, but it did pretty good. It held out. I'm not going to do any high frequency tests because I think we've got a good runner here. A few things I want to talk about though. The design of this amplifier looks suspicious, like it's been ripped off from another unit. This whole power amplifier module or board looks like the same one that I just looked at in the HK3600 receiver that I did a video a few back, and it looks like the exact same board. It's got the 2 filter caps in the center, and it's got the same arrangement of capacitors, transistors, even the bias potentiometer is in the same location. It looks like it was identically lifted and put into this amplifier. The HK3600 was 90 watts per channel. I think I measured at 90 watts per channel. I don't know, I can't remember what it's rated for. This one's rated for 65 watts per channel, and it measures out at 75 watts a channel. So it's pretty under the hood, it's kind of like just a rehash of another HK model, aside from this custom board that they built for the power on, and it's probably circuit protection in here too. I don't know if the circuit protection is on the main power board or not. Other than that, it's all pretty much standard affair. Transformer, power switch, it's all the same. Even the chassis is punched out for an integrated amplifier. It's got holes for the volume pots and the bass treble, and cutouts for the switches. You know, it's all, the chassis is pretty much recycled as well, except for the faceplate. So now we know it's running good. What I want to do is I want to check electrolytics in this machine, just to make sure that we don't have any bum capacitors. Make sure that they're all working good, and then we'll call it a wrap. But other than that, it's pretty good. Okay, so right now the amplifier's on and it's out of standby, and it's powered on, and it's consuming 26 watts of power. Now that it's gone into standby mode, it's been about 2 minutes since I shut it off. It now consumes 20 watts, so it's not really a great savings between standby and non-standby. The amplifier is still consuming a lot of power just to have it sit and idle and do nothing. You're better off to shut this off altogether or get a power bar. One of the nice design features of this Harman Kardon amplifier is they have the power supply built right here where it's needed, right between the two amplifiers. So you know, any leads are very short, and they're very low resistance, very low milliohms, and very high instantaneous current. You know, these are 13,000 microfarad caps, and they're just like an inch away from those power transistors. So they can really produce a better performance that way, I think. That rather than having, you know, an older chassis where they had wires running everywhere. And but this is a nice built unit. It's got heavy gauge speaker wires, heavy gauge power wires coming in through this tube. I was looking over this board here. This is the sensing board for sensing when to switch the power amplifier on or off, or take it out of muting. And I found one cap that was bad, so I'll replace the one cap on this board, and it's got its own little power regulation on it. And I'll check over solder joints. I'm also going to check these capacitors as well. I'll go through and make sure they're all 100%. I didn't see anything wrong with the main power capacitors, main power filters on the power test. They look very clean. There's no ripple on the signal, so I'm going to assume those are good, and because they're performing well. And we'll get this working good. So this is that failed cap that I pulled out of the auto standby circuit, and its capacitor, it's C203. It is a 10 microfarad at 16 volt, and it looks like it's a Panasonic capacitor. It's one of the mini capacitors, the miniaturized ones that you saw in the 90s. So I'm just going to connect it up and show you what it says here. Comes up at 3.1, or actually 2. Well, it's dropping. This is temperature sensitive for my fingers. Yeah. So it's dropping about 2 nanofarads, and it's got an ESR of 200K, so it's pretty much done. This was in a voltage regulator circuit, a power supply. I'll show you here on the schematic where it came from. Alright, so here's a schematic of the power supply for the PA2100. Primary, secondary, we have it switched between 4 ohm and 8 ohm for the speaker operating modes. When you have it, obviously when you have it switched into the 8 ohm, it has a higher operating voltage for the power amplifier. When you switch it to 4 ohms, it bypasses the extra windings and concentrates on this lower voltage, higher current winding, and that's what they're doing there. Now that failed capacitor I found was on this little regulator right here. The C203 is a 10 volt, 10 microfarad, a 16 volt, and that is in parallel with the Zener, and I think it was just there to keep the noise from the Zener from affecting the power supply, the circuit, this power regulation. This is just a series pass voltage regulator, 47.8 volts coming in and 14.3 volts going out, and all this little voltage regulator supply, all this does is provide voltage for the protection, I believe, and for the standby circuit. So this capacitor was open circuit. It measured at 2 nanofarads when it was supposed to be 10 microfarads. So I don't think it really affected the operation at all. It just, maybe this was starting to get noisy here. This Zener diode here is what sets the regulation for the series pass transistor. And without this capacitor, I guess maybe noise from the Zener could get through, and that might be amplified by this transistor. But it's changed now. It was working before, it's working now, and this capacitor has been renewed. So that's been fixed. So I got the bias set up on this amplifier. When I first tested it, okay, a little bit on the bias settings. When you put the amplifier, turn it on, it's going to want to turn itself off after 2 minutes. So you have to take off the automatic speaker, what is it called? Auto standby. You have to shut that off on the back so the amplifier stays powered up, so you can complete the bias settings. What you want to do is you want to have this amplifier sitting on idle for 20 minutes or so. There's 2 test points here on the right channel, 2 test points here on the left channel, and there are 33 millivolts between the test points. And when I first hooked it up, this one was bang on, and I'm monitoring it. This right channel, or sorry, left channel on the right side, it was low, down to about 22 millivolts. So I turned it up to so they're balanced and they're equal. And since I did that, the power consumption of the amplifier jumped to about 30 watts, 30 watts at idle now, when you're sitting at idle doing nothing. So I was just monitoring these, making sure they're stable, and they are, so I'm done with that. What I'm going to do is wrap this up because we're done. Nothing else to do. Replaced one bad capacitor and touched up a few dodgy solder joints that didn't look too great, and that was about it. And I think we're done. So there you have it. It's a PA2100. It's a, what do I want to say about this? Signature series. The Signature series, I think, is more just a name than anything else. I think it was just a rebranded or recycled amplifier. They took out of one of their other receivers or whatever, put it in a box, gave it a fancy faceplate, nice aluminum black. Don't get me wrong, it is a good amplifier, and it's, you know, highly desirable, but I don't think putting the Signature series name on it makes it that much better. It does have some good specs, but we'll see how it performs. I'm going to try this out and see. Another thing, along with the HK3600 receiver I gave a thumbs down to, this one's also similar in that it, you know, when it's plugged in and it's sitting in standby, it's consuming 20 watts of power, doing nothing. And then when you come along and turn your stereo on and it senses a signal, it comes alive, and the power consumption jumps to about 30 watts. Idling. So I don't understand why they have to have 20 watts of idle when the machine's shut off or on standby, and that's 24 hours a day, every day. There's a lot of power wasted. They could have done something better with the standby circuit. They could have had like a little power supply with a little tiny transformer. It would have consumed maybe 3, maybe 4 watts at the most, and they would have had their circuits energized, and a simple relay would bring everything to life. But hey, what do I know? Anyways, that's it for this one. Thanks for watching, and stay tuned because we have more stuff coming up. And yeah, looking forward to doing it. All right, talk to you later.